Hello, hello. All right. Sorry, late again. I know, right? Excuses every day. Anyways, let's correct that today. Oh, I made a mistake in the title. It's supposed to be day 63, not 62. Save changes. All right. So that has been rectified, and let's get into the stream. Um. Okay. So let's get started. Ah, honestly, I need to work on my timing and everything. This is quite wrong to start very late. But hey, it's all good. It's all good. So, what are we doing today? Linked list. A linked list question. Linked list question. A linked list question. Let's have a linked list question. So, so. Okay. Um, I'm going to solve this question here. I've spent quite a bit of time trying to understand the question and solving it. So, you can see I've not even submitted anything yet. So I'm going to do all of the work right here and the explanation and everything. So let's see. So let's read the question. I've said let's read the question like 4 times, but this time around, last time, let's read the question. You are given the head of a singly linked list. The list can be represented as L0, blah blah blah. All of these are nodes in the linked list up to Ln, right? Reorder the list to be in the form L0, Ln. Ln was the last node in the linked list. L1 and Ln minus 1, L2 and Ln minus 2. You may not modify the values of the values in the list nodes, only the nodes themselves. Okay, only the nodes themselves may be changed. Here's an example. We are given this head, and the output is this. So it's quite clear now what the question is actually asking us to do. I like link this question so much that it is, you see most of the time they give you an image, and an image is such a good thing to have because it actually shows you a visual form of the question, right? So you can see the linked list is like this, right? And we want to get, we want to, you know, we want to return, we want to reverse this is not a reversal, but we just want to modify, reorder every node in the linked list, right? So here is the original form, and here is what we have as the output. So you can see the last node became the second node became the third node became the last node. So I'm going to try and explain this problem, and we can all go through it together. So, sorry, I keep pressing that thing. Okay, let's go to the board. Oh, here is I was trying to like understand the question. This is some work I was doing before, and then I realized I was behind time to stream. But let me delete this and represent the nodes again. So we have 1, 2, 3, 4. Okay, so our nodes are 1, 2, 3, 4. I'll just represent them here. So we have 1. Okay, let me just put it as 1. I don't know, that's just an extra step to put the circle around the number. I'm feeling a bit lazy today, but let's do it this way. So 1, 2, 3, 4, and then 5, right? 5 is the last node in the linked list. Oh, there is no 5. Good. So since there is no 5, we can remove this node here. I'll just remove it this way. Great. Okay. Uh, you know what? Let me know. Let me know. Let me be fair. I'll just represent the nodes like this so that they are actually, in a proper visual representation form. So 3 is here, and then we have 4 here. Now we want to reorder the nodes in this linked list. The first idea I had, right, was actually against the requirements of the question, but it works. So one thing I was thinking is unpack every node in this linked list into an array like this. So I'll take the first node, and put it here. I'll just represent them with a simple array, right? Create a new linked list, an empty node as a new head that I'll be returning, right? And then I'll put 2 pointers here, right? I'll put a left and right pointer while iterating through this link. Now the iteration will help me build the linked list, right? And then I'll put this first node in the links in my new linked list. I'll call this new list, right? New list is going to look like this. So when I iterate through the linked list, right, I put my left pointer at the beginning of the I'll call this packed, right? Or this is an array that I packed all the values in the linked list into, and my left pointer points at the first node, the right pointer points at the last node, right? So the new in the new linked list, while iterating through this list, right, I'll be adding each value at every position. So the first value that goes into my new linked list will be 1, right? Will be 1 like this. 1 would then point to R, right, where R is. So this will be 4. So after every iteration, I'll move each pointer, right? So after the first iteration, the left pointer would have moved to this point, right? And the right pointer will be here. After adding the right pointer, I'll move the right to this point, right? And then, in the third iteration, right, I can have, so left will be here. This is going to be 2. And then in left pointer will move to right. So my condition for the iteration happening, it will be such that the left pointer has to be less. Sorry, the left pointer has to be less than the right pointer. But when they are equal, it means we are at the same node. So the iteration ends there. So I can have this here, and then I'll put the right pointer, the node or the value at the right pointer in my array at this point here. But this works, but the issue with this question is, if you read very well, the issue with this solution, I mean, is that you may not modify the values in the list node. Sorry, you may not modify the values in the list node, right? In the list nodes, only the nodes themselves may be changed, meaning we can just reorder the values in the list but not change the list. So we keep the main list itself, right, and return that same list and not a different list. All we need to do is to alter the positions of every node in the list. So yeah, so that's why this solution, even though it works, right, it will not be accepted because this is a new list that is being returned, right? This is a new list. In fact, the question is not even asking us to return anything, right? We cannot return anything. Or are we returning anything? Okay, we can do not return anything. Modify the head in place instead. So we just modify the head, and they'll get the value here. So this will not work. This will work, but it will not be accepted. So what's the next approach to solving this question? Well, another way we can do this is by using a very not so tricky method. Now, what we need to do is to take the nodes in the linked list, right? we can take half of the list, right? Half of the list, reverse that half, and then merge that half into a new list. I mean, into our first half, right? So now, when we look at this, right, we can say, so in this case here, what you might come across most of the time is reversing half of the list, but in reality we are not reversing half of the list. We are reversing the nodes after the half, right? After the half, I mean the half point or the middle node in the linked list, we are reversing those nodes instead of the actual half. We are reversing the nodes after the half, right? So in this list here we have 0, 1, 2, 3. If we're to use a fast and slow pointer, right, usually we use fast and slow pointers to target every we use a fast and slow pointer to move those 2 pointers until the slow pointer reaches the middle, right? If we had the fast and slow pointer at this position, let me do it this way: slow pointer, fast pointer, right? Like this. If we had the fast and slow pointer, the fast pointer moves twice as the slow pointer, so 1, 2, before the slow pointer will move 1, right? And then we move again, right? 1, and then we can't have, the next system. But at this point, I think the slow pointer would have moved to this position. Now, this will be considered, the half point in this node. I know it might be tricky, but if we had, okay, so this is half. What am I saying? This is this is the first half, right? So in every iteration, you know what? Let's try this out to properly verify where we are in the linked list, because the slope pointer usually gets us to the middle of the node of the linked list, but we don't want the middle. Instead, we want the node after the middle, and then we reverse that node instead. So I'll quickly write it. Okay, I have a function here. I think linked list basics here, right? Basics of linked list. So okay, I've written a bunch of linked lists here, but I can use this instead. Let me just copy everything here. I have most of the functions that will do certain things for me, so I'll copy everything. I don't want to modify whatever was there before, so let me keep it that way. Okay, so we have linked list, the linked list class, print linked list, right? Print linked list. Append, we don't need this. We don't need this either. Get value by position. We don't need this too. Insert value in the linked list. Yes, so we don't need this too. I can write a function. Okay, you know what? This is very funny because the function is actually not complete. But let's create a linked list, right? So I'll write a function here. So I'll use nums 1 up to 4, 1, 2, 3, 4, right? And then I will say for num in nums, right? In nums, I want to add every num to the linked list, so I can say reverse. This is not what we want. Print linked list. I can leave this here. So let's say add item, right? So we can say let's create an instance of that linked list. So I'll say my linked list is going to be equal to linked list like this. I think is it linked? Okay, come on, linked list here. So that is my linked list, and I will use this. So I'll say my linked list dot add right? Add item or add node, add num, right? So we add every number in the list. So I'll print this linked list quickly so that you see what it looks like. I can say my list dot print linked list here, right? So let's run this quickly, and you can see we have 1 2 3 4, right? These are the nodes in our linked list currently. Now let's get the midpoint of this node here. I just really want to verify this. So the midpoint of this node will be so I'll write a function, right? Let me just remove this to here, so I can say let me define a function, say get middle, right? Get middle will take a head. Now the head is simply an instance of a node class, so I'll put that there, and yeah, we can just return a node at the end of the day. So okay, so we'll use a slow and fast pointer, right? The slow and fast will start from the head. This is how I usually do. I usually implement mine. Other people might do it differently, but I like to start them at the same position. So while there is a fast, while the fast pointer is not pointing at none, right, and the fast pointer has fast equal to fast dot next is not none as well, right? We want to say slow should be equal to fast, sorry, slow should be equal to slow dot next, right? And fast should be equal to fast dot next. Okay, so that's about it for the fast pointer. And then when this iteration is when this loop is done, we can then return the slow pointer, right? The slow pointer would have pointed at a certain node which is in the middle. Okay, so let me even when I call this function, I will not get the value I wanted. I mean, so if I said so we'll say midpoints or mid node, which is middle node in short. So I can say this is going to be equal to my linked list dot head, right? Oh, sorry, my linked list dot head will be called into this function here, get middle. So I'll call get middle and pass it my linked list dot head. Now this is the node we want to print, and I just deleted my print function. I can still bring it back. So my print function is here. I don't want to write all of this myself because it will take time. I actually did this some time ago, so you can have access to it in the description below. So it's all in the GitHub repo. So yeah. Okay, so let's print linked list, and I'll print the mid node because the mid node is simply a particular node. So let's run this and see. Okay, something is happening, but let's print an empty string to give them space. Okay, as you can see, our mid node is at this point, right, which is 3 all the way to 4, which is this result that we have here. So for this function, right, our midpoint after moving, so this will move from, they'll both start at this point, right? They'll both start at this point. So this will move 1 2 before this moves 1, and then this will move again 1, but it can't go 2 because it's stuck at this position. And then S will also move to this point, right? So S is now at the midpoint. This is the midpoint of our linked list. Now we want to reverse every node after the midpoint and not including this midpoint here, because this midpoint will become the last node in our linked list after we are done reordering every node in the list, right? So we keep this node in the first half. I'll call this the first half. Our first half will look like this: 1, 2, 3, right? This is our first half. We need to keep this 3 in the first half, because the first half's last node, or the tail node of the first half, will always remain the last node, even when or even after we reorder every node in the list. So we keep this here, and then we take the remaining nodes, right? In other words, slow dot next, and reverse this slow dot next here, right? We reverse every node in it. So in this case, we only have one node, so it's going to be just 4, right? It's going to be 4. Let me move this back to where it was. This is going to be here, and this will be here. So when we reverse for the reversal form of this node is just going to look like this. I'll just put none here, but we don't need not for anything, so let's just keep it that way. So we have 4, right? I'll call this second half, right? Second half reversed. Rev sec, right? Reverse second half. So the reverse of the second half is 4, right? Now we need to perform another iteration. Now this is where things become interesting. This is where we start to swap the position of every node in the linked list. So our original node, keep in mind that our original node would look like this. Now we want a second half, right? We want a first half. Our first half will simply point at the head, right? Will simply point at the head, but let's just use the first half. Oh, sorry, I'll put FH as first half, and this will be from here 1, 2, and then 3, right? So now we need to iterate through this list and then swap the positions, right? Or insert the reversed every node in the reversed list into the appropriate position in the first half. Now mind you, the first half is simply a copy of the head node, right? There is still 4 and the original linked list like this, but we just, for the sake of explanation, which we should just look at it this way, that the first half is simply the first half, just from this point all the way. But for us to get the first half, we still need to point at the head node in terms of code, right? So first half is like this. Then what we need to do is to iterate based on every node in the reverse half. So while the reverse, the second reverse, right, reverse second second half second half, while there's a node in the second half, right, we want to insert that node as the next node in this first half here, right? Instead of this, it should look like this. It should become like this: 1, then the node of the reverse half, so 4, and then 4 will point to every node after the every node in after the head node, right? Every node is going to be 2 all the way to 3. So we need to change it to something like this, right? So for us to do that, we have to iterate based on how many nodes there are in 4 in the reverse form, right? And then set the next pointer of the first half, right, to the reversed node, and then the reverse node's next pointer should become every node, the next nodes in the first half, right? Let me go over that again. for us to for us to reorder the nodes, right, we know we'll take a couple of steps. First of all, we need to get the middle node and reverse every node in the middle node, every node after the middle node, sorry. So every node after the middle node in this case is 4, right? We only have 4 to reverse. So the reverse form of 4 is still going to be 4. So I'll call this reverse reverse second half, right? I'll call it RH, sorry, reverse second half, right? Reverse second half is going to still be equal to 4, right? This is a node. So what we need to do then is to take a copy of every node in the original list and call it the first half, right? Because there's no way we can get all the nodes from here all the way to here, because we use 2 pointers. The slow pointer is obviously at the middle. How do we remember every node after it, right? That's going to be quite difficult. So for us to do this in an easy way, we simply need to take the first half, right, and point it to the head of the original linked list. Now I'll call this x, right? X. So we can say this is going to be equal to x, sorry, or let's say head, right? This is head. Or you know what? Let me say, yeah, this is head. This is head. So I'll say this is going to be equal to head. Now this will take every node in the head node all the way to the where s is, or in other words slow pointer is, but we are still not concerned about that. This will simply copy every node in the original linked list, and we are okay with that, right? So what we need to do then is to iterate for every node in the reverse second half list. This is a new linked list now, but it's just a reverse form of the nodes after the first half, right? So we then take every node in this linked list and set it to the next node after the this node here, the first head, right? So this is going to look like this. So our iteration will be run based on how many nodes there are in RHS. I'll call it RSH, sorry, reverse second half, right? For every node in the reverse second half, we want to take those nodes, right, and merge them into this first half here. So how do we do that? Well, we need to keep a copy of every node after the first half. I'll call this temp, right? This is going to be temp, or temp1, which is temporary node, and this will simply be equal to the node after the head, right? The nodes after the head. So it's going to be 2, 3, whatever. Let's just put 2 and 3. So let me put it this way. So how do we get 2 and 3? We'll simply say head dot next, right? Head dot next is simply 2, 3, and 4 and so on, right? So head dot next is there. So we say we can get a second one, but in this case we don't need a second node. So what we need to do here is we say the node after this head, right, will simply be equal to the node in this reverse node here. So this is going to be equal to so fh dot next, right, or in other words the head, right? Instead of using head here, because we don't want to touch the head directly, we don't want to manipulate it directly, so I'll just say this is going to be equal to fh. So fh dot next here will now become the nodes in this rsh here, right? So this is going to be equal to what? To 4, right? This is going to be equal to 4. Sorry, fh.next is going to be equal to 4, right? So this is going to be equal to 4. So simply, then what we need to do next is to say, okay, so rsh, right, which is the reverse half, dot next now will be equal to every node that we copied in this temporary node here. So this is going to be equal to temp1, right? Temp1. And at the end of the day, let me just show you what will happen. So we'll have one like this. Let me use this. So this is our head node, right? Like originally here, fh first half, right? This is our original node. We'll take this original node, right, and copy it into temp, right? Copy the next values into temp. So the next value in this temp will be equal to will be equal to, I can't write it all here, but it will be from 2 3. Okay, from 2 and 3, right, will be our next values. And then we'll take this head here and set the next value in it to whatever RSH was, right? The reverse second half. So this is going to be equal to 4, right? This is going to be equal to 4. And the RSH.next will now point to whatever temp 1 was, which is this here, right? So we'll take it and insert all these nodes here. And that's all we need to do, right? And then in this way, we've reversed the linked list. So that's the solution to this question. Actually, an explanation to the question here. Now it's already 11:14. Sorry for starting really late today. I'll do better tomorrow. All right. So that's the end of this stream tonight. Hopefully I'll see you. Sorry. Okay, I thought I saw a chat. Anyways, that's the end of this stream today. It was really good. God willing, I'll see you guys tomorrow. Okay, and we'll continue with newer and much nicer question. Now, I did provide the code for this question today because it is just an explanation video, right? I want to explain it so that you can try it out yourself and see how well you will do, solving this question, right? So I want you guys to try it out. Whoever is here today watching the stream, based on my explanation, just try and solve this question, and I'll provide the solution tomorrow. And a new question. There's even an interesting question here. So which is similar question here. So this question is quite nice. So I would like you guys to try this out. If I had the time, I would have explained this, but unfortunately, I'll be explaining this tomorrow and then provide the code for this other question, this one here. Okay, it's a good question, and thanks to everyone that was here. Bye once again. Adios.